All right, hello everybody. My name is Daniel Alexak, the current president for CBU IEEE. And in this workshop, we're going to be going over how to solder one of these mini gaming PCBs. So there is a lot of safety and a lot of risk with this workshop. So you need to make sure you have your instructions dialed in for this one, and you know how to present soldering to the students in a safe manner. Because soldering is not a toy. It's not something to mess around with. You have a lot of students probably at this workshop who are going to be doing it at once. So you need to ensure that before they get their hands onto soldering these boards, they understand thoroughly the safety procedures and how to utilize or how to properly solder. So walking through the presentation first, there's a few things that you want to explain to the students about general board arrangement, how to place things on the board, how to correctly inspect your solders, and obviously safety. So I mentioned this in the live demonstration, but there's going to be component arrangement. And so what this is that on the PCB, certain components are going to need to be placed in certain directions. If you have an LED, capacitor, a diode, an EEPROM, anything of the sorts, your arrangement of the parts and the way they're put in do matter significantly to if the board will work or not. So there's a lot of different ways to observe this. On the components themselves, if it's an EEPROM, you'll see that they have a notch. This indicates what the top is usually. On things like LEDs, they will have longer legs. On diodes, they will have directionary signals. And for ours, we're using an EEPROM, so you'll just need to look at the top notch and see what direction it's headed in. And on the board, you need to match that up to the direction of the footprint. But we only have one of those on there, so it shouldn't matter too much. You want to explain what surface mount components are. These are essentially much smaller footprints that we usually do not solder ourselves. There are machines to solder these on, or just much easier methods to do these rather than by hand. But essentially, they're just much smaller footprints, which are actually utilized on this board, but they're already pre-installed on there for the students, so they don't have to think about this. But you can just show it to them. There are little resistors underneath the buttons, and those are surface mount components. We showed them in the PCB workshop an example of where to actually find those and see their footprint, but just quickly show those. Safety, huge part of this. So you need to make sure the students are holding everything correctly. You need to make sure they are taking care of the iron. You need to make sure they're not breathing in too much of the fumes. You need to make sure they're just being very safe with this. So do not touch any metal tip of the soldering iron. You only want to be holding it from the base like it's a pencil. The same way you would hold your pencil is the same way you will hold your soldering iron in your dominant hand like a pencil from the base. So ensure that they are not inhaling a lot of the solder fumes. We do usually have fume hoods. That is up to your discretion if you have a fume hood for every single student. It's not dangerous to inhale these fumes because they don't have lead or anything in them. They're just probably not the best for a long period of time, which it won't be. But just to be safe, don't advise that they don't lean over these fumes the whole time that they're soldering. Don't hold on to the board too long because the board and the components themselves will get very hot. The second you press that soldering iron to it, it's at 400 degrees Celsius. It's going to heat up very quickly, and it is going to residually burn the students. Don't forget, if you're putting your iron down, you don't want to just set it on the table. Preferably, if you're putting it down for a long time, you want to turn it off and then put it in a stand. But if not, then just put it in the stand itself. Make sure you are brushing off the solder from the tip every single time you put it down, just so it doesn't get all messed up. As you can see here, we have a slide on that. If you don't maintain your tip, if you just continue to leave solder on it, it will oxidize and it will get disgusting. So you want to make sure in your stand you have either steel wool or some sort of wet sponge, and you can just continuously wipe it down in between uses, and that will make sure it maintains its integrity. So here's an actual display on how to solder now that you've gone over the safety and some of the general safekeepings of how to put boards or components into the board. So you can see here, this is a few different examples of what soldering can look like depending on how you do it. You want to look for the, I don't know if I have words on here for that, but you want to look for that perfect little mountain that you can have built up. And this presentation does actually have a camera right here, so ideally you'll be showing the students how to do this. I have a live example showing you how to solder if you are unaware how to. But essentially, you just want to show them what proper wetting looks like on a solder. You want it to look more like this, where it has that curved mountain look. It's not over wetted, it's not under wetted, it's not off the pad, it's not cold, everything of the sort. You want it to look just like this. You want it to look like a mountain that is thoroughly connected. You don't want it shorted. This actual presentation is not going to serve as much of a purpose this time, because this is all going to be live display. This is going to be up to you to make sure that they have their safety and everything in between to understand how to do this workshop. So I'll send it over to the live display now. Hello, now to the live demonstration of how to solder for the soldering workshop. In this portion, I will teach you how to actually solder this board, what the connections are needed, and how to teach the students what to do for this part. So the camera angle is going to be tricky for this one, but I'll walk through it first by showing you all the parts. The 3 buttons, our screen, our dip pin connector, a switch, an AT Tiny that will not be physically soldered to the board, a CR2032 holder, a speaker, the board, your solder, and your soldering iron. It's recommended that you also have a fume hood, but that is up to your discretion. So the camera angle for this is going to be a little rough, but this is just going to be a quick demo on how to actually solder with the board, and then how to teach the students. So first things first, for our screen, they do not come pre-soldered, so you're going to need to thread the thin part of the dip pin connectors that come in the pack, like so, and you're going to have to solder this yourself. I recommend doing this for the students before they get to the workshop, but if you would like to, you can still have them do this. So as with all soldering, you touch the pin and the pad together right next to each other, and then you have your solder in the other hand, and then you go in when it's heated up and you start applying some of the solder, and you'll see it starts to melt onto the pad. You release, and now it's connected. So I'm going to go in and do that for the other 4 prongs that we have here. Again, you can see a lot of the smoke coming off, so it's probably best that you give these students fume hoods. It's not exactly lethal or super harmful to ingest these fumes. It is just tin, so it's probably not the best thing to ingest for long periods of time. But as you can see there, you get those 4 pins connected. That's kind of the connection you're looking for, with a nice dollop, but not too much, not under soldered. But yeah, I recommend doing that for the students, because that's kind of one of the weirder connections. And so the way to assemble this board, the way that I like to do it the best, is start with our battery holder. It goes on the back. You can see the box part lines up with the box on the trace. You'll solder this part. You'll put the switch in this direction. Switch goes in like that. And then you would flip to the other side, snip these pins, put the screen on, do the buttons on that side, and then just whatever order you want to do the dip pin connector and the speaker. So that's the order. I will start to demonstrate this by soldering all these pieces in now. A few of them can be a bit tricky in the way that they get soldered. Some of them don't like to go in that well. But like I said, starting with the battery holder, I'm going to push down, again pushing both the pad and the pin, and then begin to melt solder into it. This is one of the weirder pins. It doesn't exactly like to wrap around the pin very flush, just because the way the pad is. But you still get the job done. Push down, push against the pin, give it some solder, let it melt around the pad, put in a bit more. There you go. And then we will take the switch and put that in. This one can be a bit tricky. I also recommend having helping hands for the students, which are things to hold your components and also your PCB in one go. Just so, like now, I'm just using the table for this video, and it's really difficult to solder on, just because the components are not being held in very well. So again, I'm going to be pushing in on the pad and the wire, or not the wire, the prong, and then just pushing in a bit of solder. Pushing in a bit of solder. So if I were teaching this workshop, again, to students, they have some lower end, I believe, Weller soldering irons. So you're going to want to show them to get it to around 400 degrees Celsius. That's my preferred, just to make sure everything is melting fast. You're going to show them how to heat it up, how to plug everything in, the safety to never touch the tip, never touch anywhere near the tip. Hold it almost like a pencil. Do not touch the board while you're soldering because it will heat up. And don't touch the components while you're soldering because those also heat up way faster. In between all of your soldering, you should take a wet pad and wipe it off just to keep your iron clean. And those are just a few of the general upkeepings. Again, safety is going to be a big priority for this workshop because these are all very hot components, all have the potential to burn students. So please make sure you're teaching them safety before you dive into any sort of hand soldering. And so now that I have that switch on, I'm going to go back and snip these. You can keep those on. It's just more of a preference for me that it remains a bit short just to make sure nothing is touching the board on the front. So I'm going to clean that up, snip it, push this through. All right, and so now that I have that on, like I said, the next component is to connect our screen here. So this one you can actually just do on its flat surface because it does go all the way through. So once again, tapping on the pad against the prong, push in a bit of solder. You'll see it smoke up, and you made a connection. Sorry if this demonstration isn't as clear just because you can't really see what I'm doing. I'll try to extend my solder here so you can see. You're going to go from the pad here, hold it on the wire, feed in some solder. And that should give you a nice dollop at the bottom, which is what you're looking for. Again, making sure they're not over-wetting or under-wetting their solder. Too much can be damaging. It can cause shorts if it ends up being a little bulbous and touching other prongs. So make sure they're not dumping too much solder on there. Something that's just simple, not too much, not too little, just filling those holes that it has on the board. So now I'm going to be connecting the buttons. I recommend doing one at a time, and this is something that can also be used pretty easily without helping hands. You can just use the table, push that on there, push it onto the pad and also the prong. There you go. We got two more of those. I also recommend having wire clippers on hand for this instruction because a lot of these wires, or a lot of the prongs in the back, are going to be protruding, as you can see, so you're going to want to clip these before general usage. So again, pad and prong, feed in a bit of solder. It's easy as that. I have one more button now, so I'll flip it back to the other side, fill it through. My button is a little bent, you can see, fill it through, flip it to the other side, clean off my soldering iron, pad, prong, feed it solder. Simple. Pad, prong, feed it solder. Underwetted this one a little bit, so I'm gonna go back and add a bit more. There we go. Very simple. Don't need to overcomplicate things. So you're now going to take your speaker. The fitment is very tight on this, so you're gonna want to expand the prong a little bit. I just did it with pushing it with my nail. And you can see here, if it'll show up on the camera, there's a little plus on this speaker. There's a plus on the board. You're gonna want to line that up with the fitment on the board and then push it very hard through. Because like I said, this component is very tight, so you're gonna want to push that all the way through. Flip to the other side. Same deal as before. This one, the soldering of this one has always been a little finicky, just because the prongs and the pads that come with this by default, same as the battery, they tend to reject a bit of the solder, so it's not It's not a very fun component to solder, but give it enough patience and you'll get it done. There we go. Those two components on. And now for the last part, which is our dip pin connector. And what this is for the board, the AT-Tiny that we're utilizing for this, the microcontroller, can be reprogrammed over and over again to put different games on it. So almost like a DS cartridge, we're going to be using a dip pin connector so it can come in and out of the board. So for this one, first off, one of the other things I forgot to mention to teach the students, you'll notice that right there is a little square. If you were not to be, this is in the slides, but if you were not to be using a dip pin connector like that, there's a little notch on the top of the AT-Tiny right there. And that square is supposed to go in the same direction as the notch, meaning that this is the direction. It will not work if it's the other way. It will only work if the AT-Tiny is going in this direction in the same line with the notch. Now this board, this is the only part that that needs to be in a specific direction other than the battery, but that's a bit of an anomaly there. But usually on a lot of connectors that are just dip pin connectors like this, it will have a notch and then it'll have some sort of indicator on the actual board telling you which direction it needs to go. For our connectors here, it doesn't have any sort of direction, so it's fine. But do note that, and I believe that is in the slides. So make sure to teach them that and show them that on our board. And that goes for a lot of components like capacitors, diodes, other connectors like this one. They will have some sort of indicator on the board to show you which direction it needs to go. If it does not go in that direction, it will not work. Another thing to teach them, if they have something like this that has a ton of pins on it, you will probably want to teach them the idea of anchoring, where you just put one solder in to anchor the piece so it doesn't move around, and then just adjust it as you need to make sure it's in there, it's in the right position. So my thing wasn't as flush, so I just pushed it through a little bit. But anchoring is very important for components that are huge like this and just require a lot of soldering. Just making sure it's stuck in the board so it's not moving around. And now that it is stuck in the board, you can just go through and hit up every pin pretty fast. Again, pad to prong, put a little bit of solder on there. Don't be afraid to burn the board a little. You can hold the iron to the board for quite a long time. It's fine. It will just make the board hot. So again, do warn them that the board and the components do get hot very fast. This is 400 degrees Celsius. Not exactly a fun thing to get touched by. Just making sure those are all properly wetted. Get those through. This one's a little underwetted. Let me do that. All right, and so that's essentially the all the connections for this board. I should now be able to, if I get a CR2032, this is where the battery goes. You're gonna push that in. Sometimes it can be a little tricky. Push it in that direction, and then you take your programmer, and again, the notch side has to be on top in the same direction that our little box there was. Let's see. Let me get a different one because I don't believe that one has a game on it. Let me see if I can find one over here that has a game pre-installed. Take this one, push it in like so. You can see it's actually already on. There you go. So our switch on the back, the polarity is a bit messed up, so up is down, but you push it down and the game will be on, and there you go. You can play these games now, and the board is soldered. So again, making sure after this you go in with a clipper and get these components clipped just so they're not stabbing into the back of the students, and especially when you're using the 3D print, these need to be pretty flush in order to get that 3D print to be nice in there. But yeah, this is how to solder our board, all the directions that come with it. You can also clip all the pins up here just so they're not protruding. Yeah, that's all the connections for the workshop board, and that's how to teach the soldering workshop.